Hey, welcome to NASA Launchpad. I'm your host, Vince Whitfield. So hey, have you been watching this show regularly? Well, here's a quick recap to get you up to speed. Constellation Program, NASA's new plan to take us to the ISS, the Moon and Mars. 3 main parts: the Orion Crew Exploration Vehicle, which obviously carries the crew, the Lunar Lander, which, transports the astronauts from Orion to the surface of the Moon. But before all of that, you've got to get those off the ground, which is where the Ares rockets come in. Ares 5, seen here, is the cargo launch vehicle. And here's the Ares 1, an inline 2-stage rocket, which will launch Orion, its service module, and the launch abort system. So, that's the Ares 1. Now we're going to be looking at the Ares 1X. I know, it doesn't sound like much of a difference, but believe me, it's a huge distinction. The Ares 1X is actually the flight test vehicle. So while it looks a lot like the Ares 1, it's just for testing, not sending anyone out into space. How difficult is it to launch Ares 1 and Ares 1X? Well, to kind of put this all into perspective, try balancing a pencil on the tip of your finger. Not easy, is it? Okay, so let's take a look at how all of this is going to work in the test flight. Ares 1X is powered by a 4-segment solid rocket booster. Now, the final Ares 1 vehicle will actually use 5 segments. So for Ares 1X, that 5th segment is a mock-up that simulates the shape and weight. So it's as similar to the final vehicle as possible. Moving on, in the upper stage of Ares 1X, you've got the Orion Crew Exploration Vehicle and the launch abort system. Well, not really. These are going to be mock-ups to simulate the weight and shape as well. The Ares 1X will fly like a javelin, heading upward in the high arc before splashing down in the Atlantic Ocean. It will be launching at Kennedy Space Center on pad 39B, which is being modified to accommodate Ares 1X. Onboard computers will control the flight. In addition, data collected during the flight will be both transmitted to the ground during flight and stored on board. This data will then be recovered with the first stage after splashdown. Shortly after launch, the vehicle will initiate its roll control system, which will help orient it for flight. Once in its correct position, the rocket will tend to roll around its direction of forward motion. The roll control system will fire as needed to counteract this roll. Approximately 2 minutes into the flight, when the first or lower stage of Ares 1X is expended, pyrotechnic charges will separate it from the upper stage simulator. The upper stage splashes down further downrange and is not recovered. The first stage splashes down closer to shore and deploys its parachute for recovery. It's then retrieved by boat so the data can be studied. So, what kind of information can researchers take away from this? And how much? Ares 1X is only in the air for about 2 minutes before the stage separation occurs. Well, check it out. In those first 122 seconds, 149 sensors in the mock-up of the crew module will take 162 measurements. And that's just one small segment of the flight test vehicle. In all, for the 363 seconds total duration of the flight, there are thousands of unique pieces of data. You've got data on thermal measurements, guidance measurements, navigation, control, measurements that tell how much the Ares 1X is bending through the force of its acceleration as it goes from liftoff to its eventual Mach 4 plus velocity. And what might be some of the most important measurements come from right at the top of the vehicle. Mounted there will be a sensor. Each of its 6 pressure ports has at least one sensor, and a total of 8 sensors will take 50 pressure measurements per second. By looking at the data, researchers can determine whether the flight is following the predicted path. So, that's a lot of information. And of course, life's never easy. There's only a limited amount of space to store all of the information. So, with all these researchers trying to get all these measurements, they've had to whittle down and prioritise which information is most important. So, it's one big compromise, without compromising the integrity of the test flight. What measurements would you prioritise as the most important? Keep thinking about that one, because that's all the time we've got on this episode. Until next time, I'm Vince Whitfield. Thanks for tuning in to NASA Launchpad. Cheers.